Hello there, this is a geometry video. It is chapter 5, section 3, and today we are talking about inequalities in one triangle. And so to get started, I want to remind you of a section 4.2 just about a chapter ago. And in that chapter, and in that section, we had a theorem called the triangle exterior angle theorem. And we talked about what made up an exterior angle. I just want to remind you, just a review, I want to remind you that an exterior angle has to be made from, every angle has two sides, and the two sides of the exterior angle theorem, one of those sides has to be a side of the triangle, and the other side has to be an extension of the side of a triangle. So for example, if I were to extend this guy, this angle right here would not be considered an exterior angle because both of the sides of the angle are extensions. You want one extension and one side of the triangle in order for it to be considered an exterior angle. So that's what an exterior angle is. And then we had a theorem that stated that the measurement of the exterior angle theorem was equivalent to the sum of the two remote interior angles. So basically the two angles that are not next to angle 1. This is the only angle that is next to angle 1, so this is not considered the remote. It's the other two angles that are considered the remote interior angle. So basically we had in that theorem that the measurement of angle 1 was equivalent to the measurement of angle 2 plus the measurement of angle 3. Well, today we have the exterior angle inequality. And basically what it states is that if angle 1 is equal to the sum of these two angles combined, then angle 1 must be bigger than either one of them alone. It really makes a lot of sense if you think about it, and if you're not thinking about it, then let me just give you another example. It's like saying that Isaac has $30, and then Ben and Kate also have $30. So that would be like Isaac equals Ben and Kate combined. And now we don't know what Kate and Ben have. I mean, it could be 10 and 20, 15 and 15, but it doesn't matter. What we know is that if Isaac has the same amount of money as them combined, then obviously Isaac has more money than Ben by himself, and he has more money than Kate by herself. And that's basically what that theorem is saying. So here we have in a nutshell, the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. Or in other words, the measurement of angle 1 is bigger than the measurement of angle 2, and the measurement of angle 1 is also bigger than the measurement of angle 3 by itself. So combined, they're equivalent. Separately, angle 1 is larger than either one of them. Okay, so why does that matter? Well, we're going to be using that in the next theorem. So first, we want to make sure you understand the theorem. So it says here in example 1, I have a diagram up here, and it says, use the exterior angle inequality theorem to list all of the angles that satisfy the stated condition. So we want to basically list all the angles that satisfy the condition that the angle has to measure less than the measurement of angle 7. So here's angle 7, and angle 7 happens to be an exterior angle. It's an exterior angle to this triangle here. Angle 7 is an exterior angle to KML. And because it's an exterior angle to KML, 7 is bigger than 4 and it's bigger than 5. So we're going to put 4 and 5. Alright, so that's easy to see. But what's not so easy to see is also that, that angle 7 is not only an exterior angle to this small triangle. Angle 7 is also an exterior angle of the larger JKL triangle. And if you consider the JKL triangle, then the remote interior angles are going to be angle 1, and then this angle right here, which basically combines 2 and 4 together. So it's bigger than angle 1, and it's bigger than angle 2, and it's bigger than angle 4, but we already knew that. In other words, we know that angle 7 is larger than the measurement of angle 2 plus the measurement of angle 4. Okay, so you can see here that this angle, which is angle JKL, is using these two angles together. That angle right there is a remote interior angle to angle 7. And so angle 7 is also bigger than those two angles combined. So at the end of the day, I hope that makes sense, but at the end of the day, you have angle 1, angle 2, angle 4, and angle 5. That angle 7 is all bigger than those. Then we have part B. It says measures greater than the measurement of angle 6. So where's angle 6? Angle 6 is right here. So we want angles that are greater than the measurement of angle 6. Alrighty, so what do we got for that? Angle 3, if you look at angle 3 here, angle 3 is an exterior angle to this triangle. So angle 3 would be bigger than angle 4 and angle 6, and they want it to be bigger. So angle 3 is definitely one. Let's get my pen going here. What else do we got? Angle 8 is also an exterior angle to that triangle. So you can see here that on this side, 3 is an exterior angle of the triangle because it has a side and an extension. But also angle 8 is a side and an extension. So angle 8 is bigger than 5 and 6. So angle 8 goes over here as well. And I think that's it. There aren't any other exterior angles to angle 6. Yeah, okay. So those two angles, angle 3 and angle 8, are greater than the measurement of angle 6. So now you have a different diagram down here, same directions, but different angle measures here, so that you can do it-yourself number 1. And then we will go on to angle-side relationships and triangles. And basically, the triangle exterior angle inequality gives us these two theorems here. They don't have special names, so you have to write them out. There are easier ways of writing them out, but I'm going to go ahead and show you what they mean. Basically, it says if one side of a triangle is longer than another side, then, and that should say then, sorry, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So in a nutshell, this might make more sense to you. If xy, which is labeled 9, and 9 is a bigger number than 7, so xy is longer than yz. Therefore, the angle that is opposite xy, which is why I drew the arrow, which is angle z, therefore the measurement of angle z is larger than the measurement of angle x, which is opposite 7. So basically what this tells you is that the longest, the biggest angle will always be opposite the longest side and vice versa. So the second theorem is basically the same thing, only it's the converse. If one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. Again, that might sound really complicated. So basically, if you just look at this, we have here two angles. One's measurement is 45, one measurement is 100. Obviously, 100 is bigger, so angle K is bigger than angle J. So then the side that is opposite the bigger angle is going to be longer than the side opposite the smaller angle. So the side opposite K is JL, so JL is bigger than the side that's opposite J, which is KL. Okay, so again, basically the longest side is going to be opposite the largest angle and vice versa. So now we're going to use those theorems to do this example and the next example. And it says here, list the angles of triangle PQR in order from smallest to largest. Please pay attention to whether it's smallest to largest or largest to smallest. In order for us to list the angles in order from smallest to largest, I need the smallest, the shortest side. So the shortest side is going to be opposite the smallest angle. So here the shortest side is PR. And the angle opposite PR is Q. So Q has to be the smallest angle. So we put angle Q. The next shortest side is the 8.8. So PQ is the next shortest side. And so opposite PQ is angle R. So then angle R must be the next smallest angle. And the largest side, or the longest side, is this 9.1, so QR. So the angle P, which is opposite QR, must be the largest angle. So there you go, angle Q, angle R, and angle P in that order. So now if you can list, in this case it says to list the angles and the sides of triangle ABC in order from smallest to largest. You got to do both in the do-it-yourself question. All right? And then we're going to come over here, and this is basically the same thing, only going backwards. So very short video today. This is our last example. So this time they want us to list the sides from shortest to longest. So the sides are always going to be opposite the angles. So the first thing we have to do is figure out what angle F is. So we'll use the fact that all three angles should add up to 180 and subtract 45 and subtract 56. And this angle here is 79. Now that we know that, we can determine that the shortest side is going to be opposite the smallest angle. So the smallest angle here is 45, angle G, and opposite angle G is FH. So the shortest side is FH. And then the next one, the next biggest is 56, and 56 is angle H, so opposite angle H is FG. And then lastly, opposite 79, which is the largest angle, and that's angle F, so opposite F is GH. And there you go. So you're going to have, for this example, FH, FG, and then GH in that order. So now for do-it-yourself number 3, I want you to list the angles and sides of triangle WXY in order from smallest to longest. And once you have done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.